All right, getting into chapter 23. In these last couple chapters of the course, we're now getting into some introduction of calculus topics. So um, we're keeping it pretty surface level, pretty basic. Just kind of get you introduced to some of the ideas of how kind of some of the fundamentals of calculus and how that works, and some of the main ideas that we cover in that level of math. For this idea, pretty much the heart of what you deal with in calculus deals with the idea of rate of change. And rate of change, as you know it, is slope. So whenever we were in the past have dealt with the idea of slope and rate of change for a line is this formula. So we would do the change in y over the change in x. Right, so we would do the difference in the y values minus the difference in the x values. So we've also seen this as rise over run. So remember the y values obviously go up and down. So this is your rise, and this is your run from left to right. And so the change in y over the change in x, as we've seen it. Sometimes we know the y value to be stated as f of x. So in some equations you would see y equals. In other equations you would see f of x equals. And we've come to understand that those mean the same thing. So in order for me to have a y value is the same thing as for me to have f of x. So that is to say, in some cases, instead of y2, we could simply write that as f of x2. Right? And that's the same thing as having y2 minus. And instead of having y, we could have an f of x right there. So instead of y1, we might see that as f of x1. Means the same thing, it's just a different notation. So important to understand that those mean the same thing, just written two different ways. And of course, x is still x, so I would still write this as x minus x. So just understand that these two scenarios mean the exact same thing. They're both in reference to slope or rate of change. One word that we have come across before this year, as we see it in IB, is the word gradient. So they don't write the word slope. You see it as the word gradient. So again, understand all three of these mean the same thing: average rate of change, slope, and gradient. With slope in the past, you've only ever dealt with this before calculus. You only ever deal with slope of a line. In a line, slope is consistent. Everywhere on the line, the slope is the same. So it didn't matter where you were at on the line, you had the same slope everywhere on the line. But the difference is now that when you get into calculus, the use of this idea of rate of change is that when you don't deal with a line that's linear or a linear function, when you deal with some other function that's not linear, we'll now look at the slope everywhere on this function is different. Your slope is constantly changing. If you were to look at the slope on that curve right here, right, you would see, and we'll just draw a tangent line so that you can kind of get the idea. But if you were to get the slope of that line, right, that is different than if you had, let's just say you wanted the slope right here. Right, if I wanted the slope of the curve at that point, I would have a different slope. And so everywhere you're at on this function or on this curve, you get a changing slope. And so what we're seeing is if I wanted the rate of change or the slope or the gradient from where x is -3 to where x is +1, so look at what that would mean. If I'm looking at the function where x is -3, that's right here, to where x is +1, that's right here. Right? Well, because my slope is constantly changing everywhere from here all the way to here, I'm getting all these different slopes. We're not getting one slope, we're getting a whole bunch of slopes. And so what we do is we take the average rate of change. And so we're taking the average of all the slopes from here to here when we do this. So when we use this formula right here for slope or gradient or rate of change, we're not getting a constant rate of change, we're getting an average rate of change. So we're basically taking all the slopes from here to here, and we are finding the average slope, or the average rate of change within the function in that area. So all that is to simply say, if I now make use of my formula here, right, remember we do y minus y over x minus x. And so as we've seen before, let me write it this way. So again, I'm going to be doing x minus x on bottom, so 1 minus negative 3. And on top, how do you get the y values? Well, if I plug this x into the function, so f of 1 minus the y value that results from him, so f of negative 3. Again, as I stated up here in the start of the video, this is the same thing as saying y minus y. But where does this y value comes from? Right? It takes from taking a 1 as an x value right here, and if I plug it into the function, what is the y value that I get out of that? Well, we get a positive 1 as our y value. So when I plugged in a 1 into the function for x, my result was positive 1. So that's the y value. When I plug negative 3 into the function, so here's negative 3. When I plug that into the function, I come out with 4 as my y value. And so there is our slope or our gradient setup. Again, we are taking the average rate of change from here all the way to here. If I clean that up, I'm looking at negative 3 over 4. And we're going to see that as our gradient, right? Because we've always seen gradient as a fraction. So in this case, rise over run, right? Or negative 3 over 4. The book will often deal with decimals on these, so we can now write these as decimals or fractions. Right? We can write it either way, even though this is really probably more familiar to us. Anyway, again, just the idea, basic idea here is, as you're taking all these slopes, right? You have a whole bunch of different slopes all the way from there to there. This would simply be the average gradient or the average slope from this point to this point. All right. Going a little quicker through these next couple here now that you've had some background information. But again, I'm doing y minus y over x minus x. So my y value is f of 8 minus f of negative 3. That's where I get the y values over the x values, which are 8 minus 3. So if I were to say, well, what is f of 8? So 1, 2, 3, 4, 5, 6, 7, 8. Here's where x is 8. If I plug that into the graph and trace that over to the y-axis, right, I'm going to see that f of 8 is 4. So that's my y value. F of negative 3 we already saw gave us also a value of 4. On bottom, 8 minus 3 is 5. A little cleanup on that. 4 minus 4 is 0. So that would be our gradient. And again, take a look at what that would mean. Is if I go from here to here, that is a horizontal line. So a horizontal line has a slope or a gradient of 0. And again, that is clearly not the slope of this function. It is the average slope. So although if I added up all the slopes across the entire curve all the way from there to there, right, the average slope would average out to be 0. All right, one more of those. So again, I'm going to say f of 2 minus f of 0. Over 2 minus 0. So that's our general scenario there, our setup. So again, on bottom, we did the 2 minus 0. On top, if I plugged in f of 2, I'm going to get a y value of 2. If I plugged in a 0, I have a y value of negative 1. So a little cleanup on that. And we have the average rate of change, which is 3 over 2, or 1.5, same thing. All right, moving on. That was all done from a graph. We can do the exact same concept from a function. So now we're not looking at the graph, we're just going to deal with the function itself. The formula, the process, none of that changes. I'm still doing y minus y over x minus x. So again, these are my x's. All right, x is an element from 1 to 3. So again, these are my x's, 3 minus 1, those are my x values. To get the y values, I'm going to find f of 3 to get his y value, and f of 1 to get his y value. So if I were to plug a 3 into this function, well, 3 squared is 9 plus 1 over 3. So 9 plus a third is 9 and 1/3. If I plug a 1 in there, 1 plus 1 over 1 is 2. So those are the y values. These were the x values. And now the rest is calculator. Just do a little cleanup on that. At this point, with numbers that start to get a little uglier, we tend to just go with decimals. And so you'll commonly see these as decimals even in your book. So as always, we'll write those to 3 sig figs. We can write those as fractions too, and that's okay. But decimals are okay too. Moving on to one more here. So these are my x's from 3 to 8. So we're going to do x minus x on bottom. So again, this is like having x1 and x2. And to get the y values, if I plug 8 into the function, so I'm going to say f of 8 is going to get me his y value. And if I do f of 3, I'm going to get his y value. If I plug an 8 into this, so negative 2 to the 8th power, and this is where you're starting to get into some pretty ugly numbers. And so you're probably just going to go calculator at this point. But if you plug 8 into that function, you're going to come out with something that looks like this. So plugged in the 8, came out with 258.8284. So I subbed in the 8 and came out with this. Oops. 258.8284. I plugged in my 3 and I came out with a negative 6.2679. And so that would be our setup, and obviously x minus x on bottom gives us a value of 5 down there. Little cleanup, and I'm going to round that off to 3 sig figs of 53.0 is my average rate of change. So that's the main idea for lesson 1 here, is doing average rate of change. I want to show you one thing out of your book, just to show you some of what here in some of today's problems. So let me take you really quick to this. So here's a typical function that we're going to be working with. So when it says during the first hour, so keep that in mind. During the first hour would mean from 0 to 1. And so that's what we've been doing kind of in the brackets. Like on the last example that we just did from 3 to 8, this would mean in the brackets you're doing from 0 to 1 is during the first hour. During the first 2 hours would mean from 0 to 2. So my x's are 0 and 2. And I'm going to plug those in to get y values. And then obviously this would be from 2 to 4. So just a little interpretation of what you'll be seeing in the homework. But yeah, that's it for lesson 1.